All right, so here is part B of the Quiz 1 Chan, Linear Circuits 2, and it's to analyze this circuit using mesh current analysis. And now, in the previous video, we had our original circuit and we redrew it to look like this circuit that you see now. I'm not going to draw the original circuit again, but here's the circuit, and we're going to perform mesh current analysis on this circuit. So yeah. Alright, so I drew out some easy steps that I use to remember how to do mesh current analysis. And step 1 is to draw the meshes. Step 2 is to write my KVL equations. And step 3 is to just solve these equations. And however you like to solve a system of equations, whether it be substitution, elimination, or using matrices, it's all the same. So here it is. So I drew my meshes, and I have my meshes going from left to right, starting with this closed loop here. And that's what a mesh is. A mesh is a closed loop in a circuit. And my first mesh is here, which is I1, second mesh, third mesh, fourth mesh, and let's go ahead and write these equations. Yeah. Alright, so here's the equation for our first mesh, and I will explain how I got to this equation. So the way I follow a mesh, I follow it clockwise. So and in a mesh, we're doing KVL, Kirchhoff voltage law, to find our equations. So basically, we are looking for voltage, and we know from Ohm's law, V is equal to I times R. So here's how I trace out my mesh. So as I'm coming clockwise, I approach this Vs. And the way I remember my passive sign convention is once I reach a negative here on a battery, then, or a negative potential, then my term is going to be negative. And if I reach a positive potential, then my term is going to be positive. And it's pretty simple for me to understand. So here we get to that Vs, and it's going to be negative because we at that negative potential. And now we're going to have that mesh I1 times the resistance here, the 6 ohm resistor here. And that's going to give us the voltage from here to there, right? And now for our next term, we're going to have our mesh I1 coming downward from this greater potential to this lesser potential. And then we're going to have our second mesh I2 coming upward. So they're both fighting and interacting with each other to create this current in this branch right here, right? So that current is going to be I1 minus I2 times the 12 ohm resistor. And that whole thing is going to be equal to 0 because the sum of all voltage drops in a closed loop is 0. That is KVL, Kirchhoff's voltage law. So that is our first mesh. All right, so we can go ahead and move on to our second mesh. But before I write anything down, I want to show you how this is going to be quite difficult if you try to do it exactly how you did mesh 1. Because we have this current source right here, this independent current source right here. And so we don't know we're not going to know the voltage in that branch. Obviously, because you don't see any resistance there, but it does have a resistance. If you take a multimeter and measure it, it has a voltage, it has a resistance, but we don't know it, right? So we would use the concept of a super mesh to draw out that equation. And I'll go ahead and explain to you how we use a super mesh. All right. So because we have that current source right there, we're going to use that super mesh. And here's how I remember how to use and utilize the super mesh. And so since we don't know the voltage in this branch right here, right? And we know the sum of all voltage drops in a closed loop is equal to 0, we can actually, instead of writing an equation just for this mesh right here, we can opt out and write an equation for this whole loop right here, because all voltage drops in a closed loop is summed up is equal to 0, right? So, and we also have options. You know, we don't only have to use this closed loop. We can, but we can obviously use this closed loop if we'd like, or the whole circuit in the closed loop if we like, or this closed loop if we like. It's all you're still using the same principle to get your equation, so it still holds. So the way I solved this one, I used this whole, oh, let me fix I used this whole closed loop to write my equation right here along that dotted line, because and you'll see this later on in the problem as well. I have an unknown here in this equation of Vs, and I like to solve a system of equations. So in order for me to solve a system of equations that's going to come, I need another equation with this unknown Vs in it, right? So I extended my super mesh to this closed loop right here. And I'm going to show you how to write that super mesh right now. So here's the equation for our super mesh, and it looks extremely simple because it is very simple, and I'm going to show you how I wrote it. So coming from the bottom of this mesh and coming into this negative potential on this battery, I'm going to have my minus Vs. And just like the first equation, I'm going to come around. I'm going to have this mesh, I1, be multiplied with this resistor to give me the voltage right here, 6 times I1. And now I'm going to come all the way along, and I'm going to reach this branch right here and come into this resistor. And I already know the voltage across this branch is Vx, and it was given to us in the previous problem, and I'm just going to write it down here. Vx is equal to 8. Right? So we know what Vx is, and this is our super mesh here. This is our super mesh equation here, and it's gonna allow us to solve this problem a lot more simpler and a lot more easier now. So that is how I formulated the equation for the super mesh. Alright, so after I plugged Vx in, you're gonna notice that we run into a small roadblock, because we have 2 unknowns in this equation, but we have 3 unknowns in that equation. Alright, we have 3 unknowns. Even though we didn't finish writing the rest of our meshes, we obviously don't need to finish writing the rest of our meshes, because if you notice that we can write constraint equations based on what we already know about the circuit right here. We can write a constraint equation based on what we already know. So what we can observe from this circuit here is that I4 is this mesh right here. It's the current going through this branch right here. And what's the current going through this branch? Well, it's 3Ix. So we can go ahead and write that down right here. I4 is equal to 3Ix. Sweet. And like my last video, we already solved for what Ix is, and I'll explain it very quickly, but I'm not going to do all the work. So we have Ix coming in this way, we have 3Ix coming in this way, and we also have a current coming into this way. We know what the Vx is, right? Vx is 8, and we know the resistance across this resistor, which is 4 ohms. So the current coming through this branch is going to be 2 amps, right? So we have a current coming here, current coming here, current coming down here. So we can do a KCL and solve to find Ix. And then when you do that and you do the algebra, you'll get Ix is equal to -1/2. All right, so Ix is equal to -1/2, and when you solve that out, you'll get I4 is equal to -1.5. All right, so we can observe our circuit again, and let's figure out. So now we know the value of I4, right? How do you think we can formulate something to find the value of another unknown that we don't know? I3, perhaps. So just like how we formulated the small term here, we can also do that for this branch here. And so we know that this mesh I3 is fighting against this mesh here, I4, and these two currents are pushing up against each other to create the current in this branch here, right? Which is 2 amps already, because we know the voltage and we know the resistance. It's 2 amps. So the current is 2 amps. All right. So we can write an equation for that here. And I'm going to go ahead and write that. So we're going to write an equation, and that equation is going to be I3 minus I4 is equal to 2 amps, right? And we already know what I4 is. I4 is right there. So it's -1.5. And we know negatives cancel. So that's going to be plus 1.5. And if we solve for I3, that's going to give us 0.5, right? So now we have I3. This is good. We're making progress now. We're slowly, getting to where we need to be. So we want to figure out what is I2 so we can have two unknowns in our equations so that we can solve, right? So just like how we did that, we can do that again if we analyze the circuit and we see that I2 is fighting against I3 to create, well, not to create, I guess, but, well, because this current source is independent, but I2 and I3 together make up this 2 amp current source. This is how it's working. So just like how we drew an equation for our current in this branch, we can do that as well. And we know that our current is coming up through this branch. So we want to start with I3 because our current is coming up through this branch and I2 is fighting against it. So our equation is going to be I3 minus I2 is equal to 2 amps, right? And we know what I3 is. I3 is 0.5, so let's go ahead and set that. Yeah. So I went ahead and just finished a little bit of algebra on that, and we finally come to, actually, this is a -1.5. So we finally come to what we needed. We found what I2 was after starting back from I4, analyzing the circuit, and drawing equations to solve for the unknowns that we needed to get to where we know I2 now. So I2 is a known. So now we can plug that back into our equation here so that we can now only have 2 unknowns, allowing us to solve a system of equations. All right, so here we go. We're almost done. We have our 2 equations and we have our 2 unknowns. So if you're wondering how I got to these 2 equations, I did a little bit of algebra on our first mesh and our super mesh, and I'm here now with our 2 equations, right? So we can go ahead and solve our 2 equations and our 2 unknowns, right? If you're worrying about where this -18 came from, it came from right here, multiplying, substituting my I2 into this equation right here, getting that negative 12 times my I2 and multiplying it, I get a positive 18, and I'll subtract that 18 over, and that's where I get that 18 from. That negative 8 came straight from here, and this is my second one, my super mesh equation, and that negative 8's right here. So everything should make sense right now, and solving this system of equations shouldn't be too difficult. You know, you could use elimination, you could use substitution, and you could also use a matrix. I prefer to use matrix because I can input it very easily into my calculator, and it's a very smooth process. So check it out. All right, so here's how I set my matrix up. I'm not going to explain how the matrices work. I feel like if you want to know that, you can go ahead and look up a video and how to solve system of equations using matrices. But this is basically the equation on how the matrix will work and how you can solve the system of equations using a matrix. So our matrix A comes from our left side of the equation, and you want to line up your unknowns and the coefficients for your unknowns and plug those into your matrix. So we have -1 here, a -1 here, we have a positive 18 here, and a 6 here. And so in our matrix B, we're going to have a -18, and we're going to have an 8. And to solve for this matrix, we're going to take the inverse of matrix A and multiply that times matrix B. And again, if you want to understand that, go ahead and look up some videos on how to solve system of equations using matrices. But when you do this right here, you'll get another matrix with 3 and -0.833 and in a 2x1 matrix. And this value right on top is going to be your first unknown, and this value on bottom is going to be your second unknown. So here, our first unknown is 3, which we've been looking for. So Vs is equal to 3 volts. And that is how you solve this circuit using mesh analysis. And there's easier ways to do it. There's a lot easier ways to do it, but this is a way that I can stand true by, and it really sticks to me. You know, I always stick to my guns, and this is something that I can understand myself, and I encourage you to find ways that you can understand. I hope that this way shows you how mesh current analysis works, and outlines a couple steps that we use to solve this circuit. So just a quick overview on what we did. We used some KVL to create equations for our meshes. We also used the concept of a super mesh because we don't know the voltage in this branch, right? So we used the concept of a super mesh, and we used obviously some algebra. We also analyzed the circuit to find constraint equations. Always analyze your circuit when you don't know or when you're stuck somewhere. Analyze your circuit. Try to find some constraint equations using the simple laws that we learned: KVL, KCL, Ohm's law, you know. And that's what we did here to solve for a couple of these meshes. Sorry, this is my dog. He's scratching. But this is how we solved for our meshes using constraint equations from our circuit. And I went ahead and used the matrix method to solving a system of equations. You don't have to. You can use any method that you want, and there's plenty out there. And if you want to learn, then go look up a video on how to use matrices to solve systems of equations. But yeah, that's about it, and I hope you take something back from this video.